So here we are asked to write the equation of circle whose diameter has endpoints at -3, 4 and 1, 2, and we are also asked to sketch the circle. Now finding the equation of circle means we have a standard form of equation of circle. So every time if you are asked to find the equation of circle, you will be using x minus h square plus y minus k square equals to r square. Okay, so this is the standard form of equation of circle. Now in this expression we need to find h, we need to find k, and we need to find r. So hk, what is hk? This is the center of a circle. And what is r? R is the radius of a circle. Okay, so for this circle whose diameter, endpoints of diameter is -3, 4, 1, 2, if we can find the center and radius, we can find the equation. Okay, so let's draw a circle here. This is a random circle here, and we have this center C. Let me call this hk, the coordinate of a center, as a hk. Now what is diameter of a circle? How we define the diameter? So our radius is the distance from center to any point on the circle. Now what is diameter? It is the r square? No, it's radius times 2. Now in this circle, so diameter is a straight line passing through the center and touching 2 points on the circle. So let's draw straight line. It has to pass through a center, again has to touch 2 points on the circle. Okay, or if you want to draw, you can also draw it. So we can draw like infinite number of diameter. Okay, so this is also diameter if you want to draw. So it has to pass from the center. Okay, and as you said, so here, so from center to any point on the circle, this is radius. Okay, and from center to any point, this is also radius. So our diameter is 2 times radius. Okay, if you multiply radius by 2, we get the length of a diameter. Now so we are given end points of the diameter. So let me take one diameter. Okay, we don't need all of this diameter, so let me take one diameter. Okay, so this is our diameter, and the end point is given as -3, 4. So this diameter has a 2 end points. So this is one end point, this is other end point. Okay, this whole straight line passing through the center makes a diameter. So coordinate of one point is -3, 4, and coordinate of this other end is 1, 2. Our target is finding center and radius. Now what is the center? What can we say about this center? So we have a straight line joining -3, 4 and 1, 2. Now what do you think is that center? Isn't that center is the middle point of that straight line or that diameter? Okay, because so here, so this is r. Okay, so from here to here, this is r, and from here to here, this is also r. So it means this center is the midpoint of a diameter. Okay, so let's use our midpoint formula to find the center. So our center is hk, and this hk is the midpoint. And how do we find midpoint? Midpoint is average of x coordinate. Okay, so you add x coordinate, -3 plus 1 and divide by 2, and the average of y coordinates, our y coordinates are 4 plus 2 divided by 2. Okay, so we use our midpoint formula here. So -3 plus 1, that is -2 divided by 2, 4 plus 2, 6 divided by 2, and this is negative 1, 3. So this is our center HK. Now in this, what is the value of H? H is negative 1. What is K? K is 3. We know center H, we know K. Now next we need to find the radius. Now how do we find the radius? Radius is the distance, right? Distance from center to any point on the circle. So we know our center is negative. So our center is negative 1, 3. Okay. Now we use distance formula because our radius is a distance from this center to any point. Okay, or you can take other side. So let's find the distance from this center to this point 1, 2. Now how do we find the distance? Using a distance formula. So here our distance is r. So our r is, so x2 minus x1 is square plus y2 minus y1 is square. This is the general formula. Now let's call our center point as a x1 y1. Okay, and this is our x2 y2. Now we substitute here. X2 is 1, so 1 minus x1 is minus 1. Make sure to have parenthesis, then parenthesis is square, plus y2. What is y2? Y2 is 2 minus y1 is 3 square. Let's simplify. So this is the square root negative 1, sorry, positive 1, negative, negative 1. So that is 1 plus 1 square plus 2 minus 3, that is minus 1 square. So we have 1 plus 1, 2, 2 is square is 4, and negative 1 is square is positive 1, and we have square root of 5 as the radius. So radius is the square root of 5. So center is the midpoint of a diameter. Radius is a distance from center to any point on the circle. Okay, so if you take this point and a center, you will still get square root of 5. Okay, radius has to be same. Okay, any question up to here? Now we know the H, we know K, and we know R. Now let's go back to our standard form and substitute this number. Okay, so our standard form is x minus, so x minus h is square plus y minus k square equals to r square. So this is the standard form of equation of circle. Now we replace our h by negative 1. So we have x minus, then the value of h, which is negative 1, plus y minus k. Y minus our k is 3 square equals to r. Our r is square root of 5. Do not forget is square. So r is square. Now let's simplify. This is x, negative times negative 1, positive 1 square plus y minus 3 square equals to, so this is square and square root cancel, and we have 5. And this is the equation of circle. Okay. So if you are asked to find equation of circle, we always need center, we always need radius. Your center is HK, radius is R, and once you have H, K, and R, you substitute in the standard form. And this standard form will be given to you on your exam, okay? This will be given to you. Any question? So we use distance formula to find the radius, and we use the midpoint formula to find the center. Okay. Okay, so we are done with section 2.2, but not chapter 2. Okay, once we complete two sections from chapter 5, we'll be back to 2.3. Okay, and our next exam is based on this worksheet. So it covers section 2.1, 2.2, 5.1, and 5.2. Okay, now let's go ahead and start our new topic. And in our section 5.1, we'll talk about system of linear equation, okay, and inequalities in two variables. Okay, in chapter 1, we had a linear equation, right? So this is our general form of linear equation, ax plus by equals to c. Now, if we have equation more than one, then we call it system of equation, okay, like here. So we have a two linear equation. So this is one system of linear equation, okay, or we can have three. So if we have three or more than one linear equation together, we call it system of linear equation. And in this section, we will try to solve linear system of linear equation. Now, what does it mean by solving system of linear equation? So when we solve linear equation, what do we get? We get solution, right? So how many solution we get? One solution, or we may not get a solution. Okay, there is at least one solution. Now, solving system of linear equation means, now when we graph this each linear equation, we get a straight line. Now let me go to the next page here. So here, so we have this one linear equation. How do we know this is a linear? The graph is a straight line, right? So when we graph our straight line, when we graph our linear equation, we always get a straight line. Okay, so here we have a one linear equation, and this is the another linear equation. Solving these two linear equation means we are finding the point where these two lines or intersect each other. Okay, we are trying to find the coordinate of this intersecting point. Okay, so we have a two equation, we graph each of these two equations, and we look for the point where they intersect each other. Okay, this common point is the solution for this system. Okay, so this point is on this line as well as the other line. Do you agree that intersecting point is on both lines? And we are trying to find that common point. Okay, now when we are solving system of linear equation, we might have three different cases. So one case is if the two lines, they intersect exactly at one point, like this one. So they intersect exactly at one point, then our solution is unique solution, and we call that system as an independent system. So we solve system of linear equation, and if we end up getting exactly one solution, if two lines intersect exactly at one point, then that common point is a unique solution, and the linear system we call independent. Okay, now the next type, if our two lines they do not intersect, now it means they do not have any solution. Okay, finding solution of linear system of linear equation means we are finding a point where two lines intersect each other. Now if two lines are parallel, they do not intersect, it means the system of linear equation has no solution, and we call that system as an inconsistent system. Okay, so this is the second case. Now the third case, we have a line, so we have this equation, and our second equation is also the same line. Now at how many points our two lines intersect each other? Infinitely many points, right? So in this case, we have infinitely many solutions, and we call these two equations as a dependent system, and as it mentioned here, the graph of the both lines are identical. So these are the three different cases we will see. Okay, so when you are solving system of linear equation, you might get exactly one solution, okay, or you might get no solution, or you might get infinitely many solution, okay. So if you have exactly one solution means two lines are intersecting at exactly one point. System of linear equation with no solution means two lines are parallel to each other, and if we have infinitely many solution, it means those two lines are exactly same. It means we have infinitely many solutions, okay. So these are the three different cases we will see. Okay, now let's go back to our example. And in order to solve this system of linear equation, we will use elimination method. So this is the only method we will discuss here. There are different other method of solving. So here we will use method of elimination. Now so we have two equation. So let me write down these two equation. So we have negative 3x plus 2y equals to negative 5. So let me call this is equation 1, and we have 5x plus 4y equals to 12. So this is equation 2. So we have two equation, okay. It means we have a system of linear equation. If you take equation 1 by itself, it is simply linear equation. Now if you take equation 1 and 2 together, it's a system of linear equation. Now our target is finding a solution for this system of linear equation using a method of elimination, okay. Now in this method, our target is eliminating one variable. Now we have two variable, right? In each equation we have two variable. Now we have to eliminate one variable by adding or subtracting these two equation. Now what variable do you want to eliminate? You can eliminate any variable, x or y, it does not matter. Okay, so let's try to eliminate y. Now the only thing we can do is we can add or subtract these two equations. Now by adding or subtracting these two equations, can we eliminate y? So if we add, let's see what happens. If we add, so we add like terms, negative 3x plus 5x, that is positive 2x, 2y plus 4y, that is 6y, and negative 5 plus 12, positive 7. We didn't eliminate y, we still has y, right? So it's not enough. Now before you add or subtract these two equations, so how can we eliminate? So eliminating means making sum equals to 0, right? So if we can make the coefficient of y, so if we can make coefficient of y exactly same with opposite sign, then we can eliminate. Do you agree? For example, if we can make our coefficient of y as a negative 5y and positive y, and if we add these two, y is eliminated. Do you agree? So we are allowed to add these two equations, we are allowed to subtract these two equations, and our target is eliminating one variable. You can eliminate x or you can eliminate y. Now how can we make the coefficient of y say with same number but opposite sign? So we have positive 2, we have positive 4. Now how can we make okay, let's make this positive 2 as a negative 4. How can we make positive 2y as a negative 4y? Right, so for that we multiply our equation 1 by negative 2. So when you multiply every term, okay, on a both sides. So you multiply the equation by negative 2. So if you multiply negative 2 times negative 3x, that is negative 6x, negative 2 times positive 2y, negative 4y, negative 4y, negative 2 times negative 5, that is positive 10. So we multiplied our equation 1 by negative 2. And when you multiply, make sure you are multiplying both sides every expression. Now let's add this with our equation 2. So we have 5x plus 4y equals to 12. Now we are adding these two equation. Okay, so we are adding. So negative 6x plus 5x, that is negative x, negative 4y, positive 4y. Now this is 0. It means we eliminated our variable y. 10 plus 12, that is 22. We need to find the value of x. So let's divide both sides by negative 1. Our x is negative 22. Yes. Thank you. Yes, positive 6, not the negative 6. So negative 2 times positive negative 3x, that is positive. So now this change here. So we have 11x. Now we need to divide both sides by 11, not negative 1. So our x is equals to 2. So we have the value of x. So our target is finding the value of x and y, which is a solution for both of these equations. And we are using elimination method. See, we were able to eliminate y. Okay, you can eliminate x, but to eliminate, you have to have coefficient same number with opposite sign. Okay, then only we can eliminate. Now we know what is x equals to. Now next we need to find the value of y. Now how can we find the value of y? So that in order to find the value of y, you substitute x equals to 2 in one of these equations. You can pick equation 1 or equation 2. It does not matter. You will get the same value for y. So let's substitute x equals to 2 in our equation 1. Okay, or you can pick 2. So we have our equation 1 is, let me write down that, negative 3x plus 2y equals to negative 5. Now let's replace our x by positive 2. So negative 3 times positive 2 plus 2y equals to negative 5. We are solving. So this is negative 6 plus 2y equals to negative 5. You add 6 on both sides. So this is 0. We have 2y equals to positive 1. We divide both sides by 2. And our y is 1/2, or let me write 0.5. Now we write down the solution of a system of linear equation in an order pair form. So you write down x value first, then write down y value second, 0.5. And this is the solution for this system of linear equation. Okay, so you are writing this x value first, which is the x coordinate, and the y value, y coordinate second, in our order pair form. And this is the solution of this system of linear equation. Now what does this mean? So what does 2 and 0.5 mean for both of these lines? So this is the point where these two lines intersect each other. Okay, now so here, so if we draw a graph of these two lines, okay, then these two lines intersect at 205. Okay, so at this point, I think we can. So let's see and find the graph here. Okay, so our first equation, let's see. Now in order to graph these, you have to solve the equation for y. Okay, so let's go ahead and solve the equation for y at first. So we have this first equation, and if we solve this equation for y, what do we get? So solving for y means you make y by itself in one side, you add 3x on both sides and divide by positive 2. So our y is negative 5 divided by 2 plus 3 over 2 divided by x. So this is our equation 1. Okay, and equation 2 is, you are solving for y, you subtract 5x. So y is 12 divided by 4 minus 5 divided by 4x. This is equation 2. Okay, So here, in order to graph, you always need to solve for y. You add 3x on both sides, we get a negative 5 plus 3x, then divide by 2. This is what we get. Here you subtract 5x on both sides and divide by 4. This is what we get. Now let's graph these two lines, okay? So we have y equals to negative 5 over 2. So we have y equals to negative. So negative 5 over 2, that is negative 2.5. And what is the next expression? It was plus 3 over 2x. Plus 3 over 2, that is 1.5x. So this is the graph for our first line, okay? Now let's graph second line, and second line is y equals to 12 divided by 4, that is 3 minus 5 divided by 4. And is that 5 divided by, what is, okay, just let me use 5 divided by 4, then x. So this is our second, okay? So here we have a graph for these two lines, and our target is finding the intersecting point. So we need to know the coordinate of this point. And let's see what is the coordinate of this point. It is 2.205. Okay. So finding that intersecting point is solving the system of linear equation. And this 20 point is on this our blue line as well as red line. Okay. So this is what it means by solving this system of linear equation. Okay. Any question? Now, if you use a graph to solve, then we call this is a graphical method, okay? But we use elimination method. We eliminated our variable y, and we solve this system of linear equation. Any question? Okay. Now, let's go to the next example. So here we have a system of linear equation, okay? So this is our equation, this is our second equation. So let me write down this one. So we have negative 2x plus y equals to 4. Let me call equation 1. And we have 4x minus 2y equals to minus 8. And let me call equation 2. Now we are using the same method. We want to eliminate one variable by adding these two equations or subtracting. Now what variable do you want to eliminate? Do you want to eliminate x or y? And it does not matter, okay? You can always eliminate any one variable. So let's eliminate x in this case, okay? Now if you want to eliminate variable x, now by adding these two equations, will we be able to eliminate x by simply adding these two equations? So negative 2x plus 4x, we get 2x. We still have x, but our target is eliminating x. Now, to eliminate, we must have a coefficient same number with the opposite sign. Now, this x has a coefficient negative 2, and this has a coefficient positive 4. Now, our target is making these two numbers exactly same with opposite sign. Now here we already have negative and it is already positive. Now if we can make these 2x as of 4x, negative 4x, then we can eliminate our x. Now how do we make this negative 2x as a negative 4x? By multiplying 2. So let's multiply this equation by positive 2. Not negative 2, okay? If you pick negative 2, we get negative 2 times negative 2x positive 4x. And plus that 4x from equation 2, it makes 8x. But our target is eliminating our x. So let's multiply equation 1 by 2. And if you multiply, we get 2 times negative 2x, negative 4x, 2 times positive 2y, positive y, positive 2y equals to 2 times 4, that is 8. Now let's write our next equation, which is 4x minus 2y equals to minus 8. Now we are adding these two equation. So negative 4x, positive 4x, 0, positive 2y, negative 2y. This is also 0. We have 0 on the left side, and positive 8, negative 8, 0. Now 0 is equals to 0. This is true or false? This is true, right? Now what does it mean here? It means we have infinitely many solutions. Okay, when we graph these two lines, we get exactly same graph. Okay, so if you get two same number equals to each other, now it tells that we have infinitely many solutions. So here, so this is a case where we have infinitely many solutions. And we can rewrite this solution in terms of x or in terms of y. Okay, now if you want to write down the solution for this system of linear equation, you solve one of this equation for x or y. Okay, so let me take one equation. First equation, negative 2x plus y equals to 4, and let me solve it for y. So you add 2x. So our y is 4 plus 2x. So this is our y. Okay, so the solution, our x coordinate is x and our y is 4 plus 2x. So this is the solution for this system of linear equation. Or you can write in terms of y. You solve one of these equations for x, and you can have your answer in terms of y. Okay, so this is the case where we have infinitely many solutions. Now if we graph these two equations, what do we get? We get exactly same graph. Okay, so if you graph this line and this line, we get exactly same graph. So if you get two number equals to each other, okay, two same number, okay, it has to be same number equals to each other, then we have infinitely many solutions. Now in number C, so let's try to solve our number C. So here we have a negative 2x plus y equals to 4 and negative 6x plus 3y equals to 10. We're going to use the same method. Okay, now what variable do you want to eliminate? So we have, do you want to eliminate y? So if you want to eliminate y, so we have positive 3y here. Now our target is making negative 3y here. Now how can we make negative 3y here? By multiplying by negative 3. So you multiply equation 1 by negative 3. So we have negative 3 times negative 2x, that is positive 6x, negative 3 times positive y, negative 3y equals to negative 3 times 4, negative 12. Now you are adding this with equation 2. So we have equation 2, negative 6x positive 3y equals to 10. So you are adding these two equation. So positive 6x, negative 6x, 0, negative 3y, positive 3y, 0. So we have 0 on the left equals to negative 12 plus 10, that is negative 2. Now is this true or false? 0 is not equals to negative 2, right? So false means there is no solution. So this system has no solution. So no solution. And what the graph looks like if we graph this system of linear equation, we get a parallel lines. Okay, so when your system of linear equation has no solution, it means two lines are parallel to each other. If you have infinitely many solutions, then we have exactly same graph. Okay, and if we get a unique solution like our very first example, it means two lines intersect at exactly one point. Okay, any question? So we use the elimination method to solve system of linear equation. Okay, now the next here we have system of linear inequality. Now in place of equals to sign, we have inequality sign. Okay, so here we have two linear inequality. So this tells us that these two are linear inequality, and we will solve the linear inequality using graph. Okay, so we use graphical method to solve linear inequality. Now to solve this linear inequality, so we need to graph this inequality. So let's start with first inequality. We have x plus 3y less than equals to 6. So this is our linear inequality. Now the very first step is that we replace this inequality sign by equals to sign. So let's replace our inequality sign by equals to sign. That's the first step. We solve this equation for y. So let's solve this equation for y. You subtract x on both sides. So we have 3y equals to 6 minus x. You divide every term by 3. So our y is positive 2 minus, let me write this as a 1 over 3x, or let me write x term first. So 1 over 3x plus 2. You replace your inequality by equals to sign, then we have a linear equation, and you solve that linear equation for y. Now once we solve this linear equation for y, what do we call this negative 1 over 3? What is this negative 1 over 3? Slope, right? And what is this 2? Y-intercept. Okay, now we use this slope and y-intercept to graph this line. Okay, so now let's find those 2 points. So we need a Cartesian coordinate system. So this is our x-axis, this is our y-axis, this is our origin. Now how do we graph here? So we start from y-intercept. Our y-intercept is 2. So positive 1, positive 2, positive 3, positive 4, 5. 1, 2, 3, 4, 5. Okay, negative 1, negative 2, negative 3, negative 4, negative 5. Negative 1, negative 2, negative 3, negative 4, negative 5. So let's start from y-intercept. 2 is y-intercept. Okay, so this is our first point. Now let's find second point. And how do we find second point? We use slope. Okay, so our slope is negative 1 over 3. So what is this 3? Run. Okay, so you are running 3 unit. If you are taking positive 3, you are running right. If you want to take a negative 3, you are running left. Okay, so you run 3 unit right. 1, 2, 3. Then what is negative 1? Negative 1 is falling down. So you go down by 1 unit. So this is okay. So this is our final point. Okay, so the next point is here. Now if we connect these 2 dots, we get a graph for this line. Okay, now any question up to here? We had a linear inequality. We replace inequality sign by equals to sign. We solve for y. The coefficient of x is slope, and the constant is y-intercept. We are using y-intercept and slope to find these 2 points. Okay, now before you connect these dots, you have to check what kind of inequality you have. So here we have less than equals to. So if you have less than equals to or greater than equals to, if you have this equals to, then you are using solid line to connect those 2 dots. If you have strictly less than, strictly greater than, we use dotted line or broken line. Okay, so if you have equals to, less than equals to or greater than equals to, we use solid line. If you have strictly less than, strictly greater than, we use dotted or broken line. Now in our case we have equals to, so we use solid line to connect these 2 points. Okay, so this is our graph for the first one. Now we are not done here. Now this line divide our Cartesian coordinate system in 2 regions. So we have this upper region and we have this lower region, right? Now we need to find which region is solution for this inequality. Now this is the inequality. Inequality always has infinitely many solutions. Okay, we do not have one solution. And the reason we are using graphical method here is that it has an infinitely many solution and we can't make a list of all those solutions. So we are using graphical method. Okay, now this line divide our Cartesian coordinate system into 2 regions. Now we need to find which region is a solution for this inequality. For that, we pick any point from region 1 or 2 which is not on the line. So you can pick any point. You can pick any point above the line or below the line. So give me a point, give me a coordinate of a point you want to pick, but make sure that point should not be on the line. Do not pick a point on the line, but you can pick any point below the line or above the line. So negative 3, 4. Okay, let's see where is that negative 3, 4. So negative 3, 1, 2, 3, 4. Okay, so we pick this point, negative 3, 4. Okay, but you can pick any point above the line, below the line, but make sure do not pick a point on the line. Now, once we pick this point, we have to check whether this point is a solution for this inequality or not. Now, how do we check whether this point is a solution or not? So our inequality is x plus 3y less than equals to 6. Now how do we know negative 3, 4 is not a solution for this inequality? We replace our x coordinate negative 3 for x and 4 for y. So you replace your x by negative 3. So we have negative 3 plus 3 times y by 4 less than equals to 6. So this is negative 3 plus 12 less than equals to 6. So negative 3 plus 12, that is 9. 9 is less than 6. Is it true or false? Oh, thank you. I plot this point wrong, right? Thank you for correcting. So this is not here. Now, so negative 3, 4 is, okay. So negative 3 and 4, we go up. 1, 2, 3, 4. Okay. Thank you. So this is negative 3, 4. Okay. Now we want to check whether this point is a solution or not. Now, you replace your x by negative 3, y by positive 4, and what we have? We have 9 less than 6. Is it true or false? Is 9 less than 6? Is false, right? Now, if false means every point, now since this point is above the line, every point above the line is not a solution. Every point below that line are the solution for this inequality. Okay, so we show that by drawing downward arrow at the end. So here it means every point, so every point below this line is a solution for this first inequality. All this yellow region is a solution for first inequality. Okay, now we do the same thing for our second inequality. Okay, any question up to here? Now let's take our second inequality. So our second inequality is negative x plus y, negative x plus y greater than equals to negative 2. You replace your inequality by equals to sign. So we have negative x plus y equals to negative 2. You solve this equation for y. So you add x on both sides. Our y is x minus 2. Now what is slope for this? So 1 is our slope, right? And what is negative 2? This is y-intercept. Now let's graph this line. And you're going to use the same Cartesian coordinate system to graph, okay? So we start from negative 2. So negative 2 is here. So negative 2 is here. Now how do we find the another point? We use slope. Our slope is 1. Now where will be our next point? You move 1 unit right, 1 unit up. So from here you move 1 unit right, 1 unit up. So this is our second point. Now before you connect these two dots, you have to check your inequality. We have equals to sign here, so we are using solid line. Okay, so we use solid line to connect these two dots. Now this line also divide our coordinate system in a two regions. So we have this region 1, region 2. Now which one is the solution? Okay, so is the point above the line is solution or below the line? For that we find a test, we need to know the testing point. So what point do you want to pick? Pick one point, but make sure do not pick on the line. You can pick any point below the line or above the line. So you want to pick the same point?
No, I'm saying like the line, which one did you start? Like the second line.
Repeat that one more time. What do you mean?
So is it 2, 0, with negative 2, or 2, negative 0?
So negative 2, 0. Can anyone just rephrase what is that? Okay. So we can just talk that after class. Okay, I'm not sure what you're asking, but let me help that after class. So here we will pick any point below the line or above the line. Okay, any point. So let me pick origin 0, 0, right? So let's pick this 0, 0. Now we want to know whether 0, 0 is a solution for this inequality or not. And how do we know that? You replace your x by 0 and y by 0. So this is the inequality. So you replace x by 0 and y by 0 greater than equals to negative 2. So we have 0 greater than negative 2. Is it true or false? Is 0 greater than negative 2? It's true, right? It means every points towards 0. So every points towards origin is the solution, and we indicate by point by this arrow. Okay, so every point above this purple line is the solution, and we set this region. So every point. Now, do you see that common, wow, Okay. So do you see that common reason here, common solution? I should have used a different color here. Okay. So let me use green. It does not help. Maybe red. Okay. Do you see this common? Or let me use this line here. So this indicates the solution, okay? And this common reason. So every point here, these are the solution for this linear inequality. Okay, let's do this mock.